Hello, nurses. Okay, so a couple different things we're looking at on this worksheet. We're actually looking at quite a few different things. We're looking at dosage calculations, some IV calculations. There's a couple dosage calculations on here involving weight. So we're looking at a lot of different things on this worksheet. The first thing I want to talk about are just basic dosage calculations. One's involving this particular formula. This is one I use in my class, my other math classes, when I teach dosage calculations. One's on your all's worksheet that we were looking at today. Using this particular formula, one's like 1, number 2 is an example, let's see, maybe number 3. Well, looking at these, let me just tell you what I mean by D divided by H times Q. D stands for what the doctor has ordered, or the dosage ordered. However you want to remember that. That's just what the doctor has prescribed. H is the dosage that we have on hand, or how that medicine comes, or what we have. However you want to remember that H. And then Q stands for quantity. In a particular problem, any problem you have, H and Q will always be listed together. So they're always going to be together in the problem. For instance, if I said that I have 10 milligrams per tablet, my H would be 10 milligrams, and my Q would be per tablet, or 1 tablet. If I said that I have 20 milligrams per 5 milliliters, my H is 20 milligrams, my Q is 5 milliliters. They're always going to be listed together. So looking at a particular example, let's look at number 2 on your worksheet. The worksheet says the doctor orders atropine, I don't know what that is, but you all know what that means, 0.2 milligram IV. So again, that's what the doctor orders. So in my D over H times Q formula, 0.2 milligrams is the D. So I need my H and my Q from this problem. The solution you have available is atropine 0.4 milligrams per 2 milliliters. When it's listed as 0.4 milligrams slash 2 milliliters, that's the same thing as per 2 milliliters, meaning for every 2 milliliters of that liquid solution, a patient's going to receive 0.4 milligrams of that pure drug. If they were to double the amount of milliliters, if they took 4 milliliters, then they would take double the amount of that dosage. So they would end up getting 0.8 milligrams of that pure drug. So in my H and Q then, H would be 0.4 milligrams, and my Q in this case is my 2 milliliters. So I'm going to take it times 2 milliliters. How D over H times Q works is D and H must be the exact same unit. In this case, they are. I need them to be the same because what happens is I want them to cancel out as far as just the units go, because the unit I want left over in this problem is the unit of my quantity, because the answer will be that unit. Meaning I'm going to have to, when I calculate this out, I'm going to tell my patient to take so many milliliters. So it's going to match. So what I do is I take D divided by H, so 0.2 divided by 0.4 gives us 0.5, gives us just half. Then I'm going to take that answer, and just as my formula tells me, I take that and then multiply it by 2. And 0.5 times 2 will give me the answer 1. So I will tell this patient to take just 1 milliliter. And if you think about it, think about how that medication comes. It comes in 0.4 milligrams per 2 milliliters. So again, for every 2 milliliters that a patient would take, they get 0.4 milligrams. But the doctor has ordered half of that. They have ordered only 0.2 milligrams, which is half of 0.4, which means that they're going to take half of the 2 milliliters. That's why they end up taking 1. I hope that makes a little bit more sense. Let's do another one just like that. In fact, let's do, looking at number 1. Let me erase this for you here. So looking at number 1, hang on. Well, okay. So number 1 on your worksheet says that the doctor orders 30 milliequivalents. So that's the doctor's order. So that's D, milliequivalents. Now I need H and Q. So let's see, looking at it, it says the label reads 20 milliequivalents per 30 milliliters. So my H would be 20 milliequivalents, and it says per 30 milliliters, that's my quantity, 30 milliliters, so that's going to be over there in the Q. So just as my formula tells me, I'm going to take 30 divided by 20, which gives me 1.5, and I take that and multiply by 30. I would tell this patient to take 45 milliliters. And the reason why I was able to divide those two is because D and H were in the same unit, so we were good to go there. Number 4 is very similar, but we're actually going to come back to number 4 after I show you number, where was that one we looked at earlier? Look at number 11. I'm going to give you guys a second. Go look at number 11 on your worksheet, the one that starts with the nurse practitioner. Okay, so looking at that particular one on your worksheet, again, number 11, it says the nurse practitioner orders levothyroxine 0.1 milligrams by mouth daily, start first dose now. Okay. Each tablet is labeled 50 micrograms. So how many tablets will you give? Tablet medications, whenever we're putting these into the, again, it's this formula, D over H times Q, over H times Q. Whenever we're putting this in tablets, the medication, the dose of a tablet is always assumed to be per 1. So my quantity, anytime we're dealing with tablets, will always be 1 tablet because it's always so many milligrams per tablet or so many micrograms per tablet and so on. And that's what's taking place on number 11. So the nurse practitioner orders 0.1 milligrams. Sometimes they give us this extra information like the by mouth, daily, start first dose now. That's stuff that we don't need right now. I only need the dosage that was ordered. So the dosage ordered here was 0.1 milligram. The dosage that we have, so each tablet is labeled that it's 50 micrograms. So 50 micrograms, again, per 1 tablet. So our quantity in this case is just 1 tablet. So like I mentioned earlier, D and H have to be the same unit. In this case, we have milligrams and micrograms. They're not the same unit. Doesn't matter which one we convert, as long as we get one to the other. I could take that unit on top, the 0.1 milligrams, and convert it to micrograms, and therefore my D and H would both be in micrograms, and that would work. If I wanted to do the opposite, and convert the 50 micrograms and convert it to milligrams, that would be fine too, as long as they're both in milligrams. Either way, it works out. So I'm actually going to take that top one, the 0.1 milligrams, and I want to convert it to micrograms. So this is where, in order to take milli to micro, remember that's the use of, now whichever way you were doing it, either using the way that we went over in my class, it was moving the decimal, using that kiss hairy dogs but drink chocolate milk mom table. Or some people were taught the stair-step method since then, and milligrams to micrograms would be multiplying by 1,000 one time. Either way, 0.1 milligrams, converting that to micrograms, gives us 100 micrograms. So now that they're both in the same unit, now I can go ahead and divide. We take 100 divided by 50, which gives us 2, times 1 gives us 2 tablets. We would tell this patient to take 2 tabs. I hope that helped. Remember, D and H have to be the same unit. So let's go back to number 4 now. So number 4 is also using this exact same formula, using the D divided by H times Q. However, this one's a little bit different in that it's asking us to incorporate weight. So it says that a nurse practitioner orders Dilantin 15 milligrams per kilogram IV now. So let me explain a little bit what that means as far as the dosage. 15, wrote that wrong, milligrams per kilogram. So what that means, for every patient that we have, they're going to take 15 milligrams per kilogram of weight. So meaning a patient who weighs 1 kilogram, which is impossible, but if a patient weighed 1 kilogram, they would only have to take 15 milligrams of this drug. Whereas if we had a patient who weighed 2 kilograms, they would have to take double the amount of drug. So they would take 30 in this case. If a patient weighed 3 kilograms, they would have to take triple the amount because they weigh 3, so they would have to take 15 milligrams for every kilogram. So they would end up taking 45. So you see what's happening here. However many kilograms a patient weighs, we multiply that by this dosage, 15 in our case, and that will tell us what they require as a heavier patient. We have a patient who's only 96 pounds. So 96 pounds, again, pounds is not kilograms. So what I have to do here is first convert this to kilograms in order to figure out how much they are going to be able to take. Going back to what we know about pounds and kilograms, we know, this is using a known and unknown, we know that 1 kilogram is the same thing as 2.2 pounds. So if we have 96 pounds, in order to figure out what that is in kilograms, I simply just take that and divide it by 2.2. And that will give me my weight in kilograms. And 96 divided by 2.2 is about 43.6. Okay. So we have a patient who weighs 43.6 kilograms. So again, any patient gets to take 15 milligrams for every kilogram that they weigh. Our patient, who weighs 43.6, they're going to take 43.6 times the dosage of 15. So 43.6 times, 43.6 times 15 is about 654. So let me erase this real quick and let me show you a little bit what I mean. So that means that they're going to need 654 milligrams of this drug. So that's the same thing as saying this is what's ordered. Going back to our D over H times Q formula, if this is our ordered dose, let's go back and read the rest of that problem. You have available Dilantin 10 milligrams per milliliter. So how many milliliters is this particular patient going to receive? Well, they need 654, so that's our D, and our D divided by H times Q. So let's ignore this over here. So that's our D. Our H is going to be how that medicine comes, so 10 milligrams per 1 milliliter. So in calculating this out, I would take 654 divided by 10 to get 65.4. So this patient would receive 65.4 milliliters of this IV. So those are some examples using dosage calculations. So when I'm given an ordered dose and then it tells me how much, how that medication comes, and then it wants to know how much we're going to deliver, that's a dosage calculation. So based on that, that information given, we can figure out we're going to use that D over H times Q formula. Now, the other questions on here, you've got quite a few other questions asking us about IVs. IVs are a little bit different, so there's a lot of them using those D over H times Q. But there's a couple that are asking us about milliliters per hour or drops per minute or calculating the time, how long an IV is going to take, or how much total volume is going to be received. So there's a couple formulas that you want to follow on these. We went over, there's actually four different formulas based on information that's given to you in a problem. That'll tell you what we need to figure out about that problem. So going to, for instance, say number 13. So go ahead and go over to page, or I guess it's the third page, number 13. Looking at that, so we're looking at all our different IV formulas here. And this is our first one. Our first IV formula is asking for milliliters per hour. Milliliters per hour is another name for that would be the flow rate. Flow rate is usually milliliters per hour. So if you hear me refer to flow rate, you know what I'm talking about. Okay, so number 13, it says you are administering Unison 200 milligrams diluted in 100 milliliters. It's given us some extra information. That it told us how it was diluted, and we didn't really need to know how it was diluted. All we're looking for here, if you can tell by the units that it's asking for, it says what rate will you set the pump at using milliliters per hour. So to calculate milliliters per hour, there's the two units we need right there. We need milliliters and hours. So milliliters is a volume. So we need to be given a total volume in milliliters. And then because it's per hour or over hour, we're going to take it, we're going to divide by that time in hours. So these are the two units I'm looking for, milliliters and hours. And in this particular problem, it tells me that I have this solution diluted in 100 milliliters. So actually, there's our volume right there, 100 milliliters. That's really all I need right there. What I need to do is take that volume and divide it by the time. However, it says it is ordered to infuse over 90 minutes. 90 minutes is not the unit I need it to be in. In this case, it has to be hours. So 90 minutes converted to hours is actually an hour and a half. Another way to think about it, remember there are 60 minutes in an hour, so you can tell based on 90 minutes, I have over an hour. So if we were to take 90 divided by 60, it would give me 1.5 for my hours. So if they're to receive 100 milliliters in 1.5 hours, if I took 100 and divided it by 1.5, it gives me about 66.66666 repeating. So it gives me about 66.7 milliliters each hour. So if you ever want to calculate just how much they're going to get in an hour, all you have to do is take your total volume divided by your time in hours. I think there was another one in here that may be a little bit easier than that. Let's find more milliliters per hour. Number 14 was a weird one. I'll explain number 14 later. That one was actually kind of a trick question. Number 14, the answer on that one is 8, because on that one it tells us that we have the solution is 1 liter with 1,000 units of insulin. That's how the pharmacy has mixed the solution. Well, 1 liter, thinking back to your metric chart, 1 liter is actually the same thing as 1,000 milliliters. So what they pretty much say on that problem is that they've taken 1,000 milliliters and mixed it with 1,000 units. Well, so what that means is it's a 1-to-1 ratio. 1,000 milliliters for every 1,000 units means that if they're given an insulin drip at 8 units per hour, that's the exact same thing as 8 milliliters per hour. So number 14 was kind of a trick question because they actually went ahead and gave you the milliliters per hour, but they tried to trick you and gave it to you as units. So that one's kind of a strange one. But another one involving milliliters per hour to get the milliliters per hour flow rate. Okay, number 20 is a great example. Number 20 gives us just that. It says it gives us the total volume that we need, and it gives us over so many hours. It says the doctor orders 1,000 milliliter bolus of 0.9% NS, which is just simply what's in the IV bag, to be infused in 2 hours. What will you set the infusion pump at in milliliters per hour? Well, it tells me that I need 1,000 milliliters over the course of 2 hours. So we need to divide this up evenly, is what's being told to us. If we need to give a total of 1,000 over the course of 2 hours, if I took 1,000 divided by 2, that means that patient's going to get 500 milliliters per hour. So anytime you need milliliters per hour, you simply just take your total volume divided by your time. You need those 2 units, milliliters and hours. If they're in anything else, make sure you get them to milliliters and hours. So meaning if they're in minutes, you have to divide by 60 to get them 2 hours. If it would be anything besides milliliters, but if it's in liters, we know how to convert liters to milliliters by moving our decimal point. Couple other things that are asked of us on this particular worksheet using IVs. There are a couple questions not asking us about the flow rate, but maybe about the time. Like, for instance, number 18. So I'm kind of backtracking a little bit, but they're all kind of mixed up. Number 18, it gives us the total volume and the flow rate. So it's asking us about the time, about how long this will last. So this is a different formula. So again, just going through this one, number 18 says that the doctor orders 1,000 milliliters of NS to run at 75 milliliters per hour. So that means this patient is getting 75 milliliters per hour. They're going to get that once, then they get it the next hour. Then they get 75 the next hour, then 75 the next hour. And they're going to do that until they reach that total volume of 1,000. So in order to figure out how many hours that's going to take, we simply take that total volume, so the 1,000 milliliters, and we're going to divide again. We're going to divide it by the flow rate, which is 75 milliliters per hour. And you can see what's taking place with our units here. Milliliters and milliliters cancel out. Leaves me with my answer unit, which is hours. So if I take 1,000 divided by 75, what does that give me? Should give me about 13.3. So we can just round that to about 13 hours. I don't know how specific your all's teacher is going to be, but 13.3 I'm sure would be an acceptable answer too. I doubt she wants you to convert it to hours and minutes. But if she does, come see me about that later. I'll explain it. It's super easy. But that's your time. So to calculate the time, you simply just take your volume divided by your flow rate. And we'll touch on that again. Another one would be, where is that one that was asking for the total volume? There was one that was asking us about the total volume. I can't remember where that one was. So if you're asked about the total volume of an IV, meaning if you're given the flow rate and you're given how many hours they're gonna use this, then you can figure out based on that the total volume that patient's going to receive that medication, or the total volume of that medication. I'm sorry, guys, I'm having a hard time finding where that example was. Let me just give you a random example since I'm having a hard time finding that one. Let's say that, number 9. No, not number 9. Just kidding. Just kidding. Okay, let me just give you an example. Let's say that doctor orders a particular IV at 75 milliliters per hour, so at that particular flow rate, over the course of 12 hours. So with these two bits of information here, we should be able to figure out how much total volume they're going to receive. Again, they're going to receive 75 milliliters per hour. Then they're going to receive, for each hour. So 1 hour they're going to receive 75. The next hour they're going to receive 75. The next hour they're going to receive 75. So they're doing that a total of 12 times. So the easiest way to figure that out would be to take 75 times 12. And that'll give me my total volume. And 75 times 12 gives me about 900 total milliliters. So if you're looking for if you're looking for the total volume, you simply multiply. The last formula that we looked at in IVs is to look at the drops per minute. So drops per minute, an example of drops per minute would be number 16. Let's see. No, wait. Actually, let's take a look at number 17. Number 16 is one that gives us a little bit more information than we need, but I can come back to that one. Let's do 17 first. An IV medication with a volume of 100 milliliters is to be infused in 30 minutes. The set calibration is 20 drops per milliliter. So calculate the drops per minute flow rate. Drops per minute is it's kind of a unique formula in that when we're looking at drops per minute, GTT is the abbreviation for drops. To calculate drops per minute, we need 3 things in this case. And all the IV formulas that we've looked at so far, we only need 2 things. We're either going to divide 2 things or we're going to multiply 2 things. But in drops per minute, we need 3 things. We need a volume, and a volume that must be in milliliters. If it's in anything else, put it in milliliters. We're going to divide it by the time. Because we're calculating drops per minute, I need that time to be in minutes. And then what we're going to do with that answer, when I divide those two, I'm going to multiply it by what's called a drop factor. In other words, the drop factor is usually given in drops per milliliter. So in our number 17 there, that's the 20 drops per milliliter. So looking at number 20, I'm just going to do this one up here to the side. Filling out this formula, volume divided by time multiplied by drop factor. In this particular case, they gave us all three of these in the right unit. So we have 100 milliliters. I'm going to take it and divide by my 30 minutes. A little side note on this, if for any reason this is not given, so our time, if for any reason our time is not given in minutes, it'll be given in hours, and hours to minutes would be to times 60, to multiply by 60. The opposite of what we did in one of our example problems earlier, because earlier we needed our time to be in hours, and it gave it to us in minutes. So what we did with those 90 minutes is we divided by 60, and it gave us an hour and a half. Here, if for any reason, if it's not given in minutes, we multiply it by 60, and that'll give us our time in minutes. In this case, it already gave it to us. So what I'm going to do then is I'm going to take that and I'm going to multiply it by our drop factor, which is 20. So I simply take 100 divided by 30, which gives me 3.33333. Multiply that by 20, and it gives us about 66.7 drops per minute, which drops, usually you can't regulate, you can't give 0.7 of a drop. So usually that'll be rounded to the nearest whole number. So this would actually be about 67 drops per minute. Let me do another one. With those drops per minute, like I said, those are a little strange, but let me write the formula back up here at the top. But let's go ahead and let's go look at number 16 now. So again, it's volume over time multiplied by our drop factor. I'm just going to call it DF. Units are drops per milliliter. Okay. So looking at number 16. Number 16, like I said, gave us a little bit of extra information. It said the physician orders Rosafin, I don't know what that is, Rosafin, 1 gram in 100 milliliters IV every 24 hours. Here's the only thing I need from that. I need the volume. The volume that they gave me there was 100 milliliters. They gave me a lot of info there. But I know that 24 hours looks like the time, but it says to give it every 24 hours, so over the course of a day. But it says that it is to be administered over an hour. Okay, so if it's supposed to be administered over an hour, remember, our time needs to be in minutes. So we're actually going to divide by 60 minutes, because 1 hour is the same thing as just 60 minutes. And then it says calculate the flow rate using a drip factor of 15. So I'm going to multiply that by 15. So in this case, if I take 100 divided by 60, I get about 1.666666. So I'd multiply that by 15, and it gives me 25. So I would get 25 drops per minute in this case. I hope that helps. I know with IVs there's a lot of different formulas, and we went over 4. So just to kind of give you a refresher on those different IV formulas, for IVs, to calculate drops per minute, you simply take your volume, again, must be in milliliters, divided by the time, which must be in minutes, and multiply it by your drop factor. Drop factor will always be given to you as drops per milliliter. So that was our drop factor. Okay. And that, you probably won't have to convert much on that. The next formula we looked at is if I'm calculating the flow rate. So let's just call it the flow rate. Flow rate, remember, is milliliters per hour. It's probably going to be asked in a question. It'll probably be asked to calculate milliliters per hour. But that's what we need. I need the volume in milliliters, and I need my time in hours. And I simply divide by one by the other, and it'll give me milliliters per hour. So that's our flow rate. The other two formulas are based on that one that's written in red there. Flow rate, volume, time. It's just rearranged. If they only gave us the volume and the flow rate, then they're probably asking us for the time. And in order to calculate the time, what we should have is our volume in our milliliters, and we divide it by that flow rate. So flow rate, again, milliliters per hour. And And then the other one, the last one, is if they gave us the flow rate and the time, we should then be able to calculate the volume. So if I'm trying to calculate the volume, hang on, let me get this here. If I'm trying to calculate the volume then I would be given, like I said, the flow rate and the time, and we take our flow rate in milliliters per hour and multiply by the time. And those are our 4 different IV formulas: drops per minute, flow rate, time, and volume. It's a matter of, as far as looking at this worksheet and saying, when do I use which particular formula, pay attention to the question being asked. If it's asking what is, calculate the drops per minute, you know that you're going to use that drops per minute formula. If it's asking to calculate the milliliters per hour, then I use the milliliters per hour or flow rate formula. It may say, how long will this IV take? Then you know you're looking at your time formula there. Or how much total volume will be received. Then you know you're going to look at your flow rate. Your volume formula down there at the bottom. All the other ones, the ones at the beginning of the, what we did at the very beginning of this video using our dosage calculations, you know when we're going to need the dosage, the D divided by H times Q, because you'll be given the dosage ordered and how that medication comes. If you guys have any questions with it, you can always call me and I'll be glad to go over it some more. I hope this helps a little bit though.